Alrighty. That goes away, and when I pull up a question, you're going to notice that there's a number right here. Now, those of you that have a book, I want you to turn to your book, 5.1, and look in the homework section of your book. Now, just if you don't have a book, that's not a big deal. I just want you to look and see what this is. When you turn to 5.1, you're going to see a section of homework that follows 5.1. You'll have 10, 20 questions in there. This number right here, when you send me a homework question, ask my instructor, this number right here is similar. I don't know how to spell similar. Is it similar?
That's right.
That's right. Similar to the book homework problem. Number 51. So if you look at number 51, anybody got it yet? Where's the homework from 5.1? What page is it on? It'll follow 5.1. There it is. What page?
211.
211. Now turn to, what number did I say? 751. That's on page 212. It's similar to number 51 in the book. So if I go over this problem, what you ought to do if you got a book is mark that problem in your book because that's what it's similar to. This number represents the number online. Number on online homework. So if you printed off your online homework and you put it in your notebook, this one is one like number 14. You need to know those two numbers and what they stand for, okay? All right, now this one, let's do them in order because sometimes it doesn't put it in order. So let me see what this one is. That one is 57. That one is 51. Okay, so 51 it is putting it in order. Sometimes it doesn't. All right, now I can already tell we need to do a little bit of instruction before I actually do this because this is the first day of class, so we're going to go ahead and I'm not going to do these questions. We might do these questions as examples of what I'm going to do today, all right? So, with that being said, let's go ahead and talk about factoring because that's what we're doing, factoring. What is factoring? Factoring is something you heard in algebra and you have no idea what it means. Well, factoring is basically breaking up into what? Parts. Now that's a Hubertism definition. You're not going to get a definition like that in your math book because you might understand it. Okay? So, breaking up into parts. 90% of you, if I asked you, did it rain?
Yeah. Mm-hmm.
When did it rain?
It was trying to rain.
If I asked you a question like, what are the factors of 54? 90% of you will say 6 times 9, right? Why would you say 6 times 9? Why don't you say like the 10%, the guy in the back going, that would be 2 times 27? Nobody says 2 times 27. Why did everybody say 6 times 9? Why? Because it was your multiplication tables. All right? 6 times 9. So I just factored 54. That's what factoring is. Factoring is breaking up into its parts. 54 factors into 6 times 9. Now, you could break it up into what? 2 times 27. Nobody ever does that, but I factored into 2 times 27. If I want to factor 2x, factor it into 2, 1 times 2 times x. You could factor into 3 parts, you could factor into 5 parts, you could factor into 2 parts. Okay? If I tell you to factor 2x squared or 4x squared, 2 times 2 times x times what? X. See, I factored that into 4 parts. Factor is a 25-cent word for breaking up into its parts. Now, there's 2 types of factors. Okay, we're going to go into that. But the first thing you need to understand is what the heck does factor mean? Because I guarantee you there's somebody in here that was in algebra a long time ago and never understood what the word factor is. And if somebody just told you to break it up, you'd understood it a whole lot better. All right? But that's what factoring is. It's breaking something up. I'll even give you one that you probably saw in algebra. X squared plus 4x plus 4. Well, that's a trinomial, but how do you get that? Well, you broke it up into x plus 2 times x plus 2. And if you will learn the algebra, if you did learn the algebra, you'd know if you multiplied these two, just like 6 times 9, you would get this right here. Everything is factorable. Everything on a car is factorable. Can you take the brakes apart on a car? Yes. Can you take the engine apart on a car? Yes. Can you take the car door apart? Yes. Everything on a car is factorable because the car was created by putting things what? Together. How about a concrete block? A solid concrete block. All right, now that's a little bit different. All right, that is made of one element, but it can be broken into its parts, but you can't do it once it's cured. I mean, once it's together, only thing that's going to break it up is a hammer or a piece of dynamite or a stick of dynamite. But what I'm saying is, if something is put together in parts, then it can be taken apart. Okay? So that's what factoring is. Now, there's 2 types of factors. Okay, there's 2 types. There's regular factorization. And then there's prime factorization. Okay? Regular factorization just uses composite numbers. Which means 6 times 9. All right? Prime factorization uses the prime numbers, which are your ugly numbers, which are the ones that only go into itself and 1. Okay? Prime factorization uses only prime numbers. We're going to forget about this. The reason we're going to forget about this is because that's not going to help us. Okay? This is going to help us. Now I'm going to give you an example of prime numbers. 1, 3, 5, 7, 11, 13. What's the next one? What's the next one? What's the next one? 23, Hubert. What's the next one? You're supposed to be thinking. Okay, what's the next number that's only divisible by itself and 1? Well, okay, let's say 24. No, it has a bunch. 25. 25 is 5 times 5, so that's not it. 26. 2 times 13. No, that won't work. 27. 29. What's the next one? and so on. Now, what do all these numbers have in common? And actually, you could put a 2 here because some mathematicians fuss and fight about number 2 because 2 is only divisible by itself in 1. Okay, so that blows the whole odd thing out of the water. And you can't say odd because 9 is not in there. And 9 is an odd number. So you can't say all odds. You can't say all evens because there's not hardly any evens in there. Okay, so there's no pattern. There's only one thing in common with all those numbers. They're only divisible by 1 and themselves. Now, if you don't know those numbers, you need to learn them because the most important ones are 2, 3, 5, 7, 11, and sometimes 13. Those are the most important. Now, this is a Hubertism. This is something that I teach and you don't see in too many other classes. All right? When you're talking about prime factorization, that's what you're talking about. You want to break it up in terms of those numbers. If those numbers don't go into it, chances are it's going to be another prime number. Okay? Now, why do we need to break it up in prime factorization? Well, I'm going to show you why. This is kind of a for your information. You don't have to write it down. Prime factorization gives us least common multiples and greatest common divisors. Okay? And if we know how to find the least common multiple, we know how to add and subtract fractions because we get a common what? Common denominator. Now, the reason I'm showing you this flow chart is because people don't really learn how to do this. And if they can't do this, then they can't do what? They can't do least common multiples. And if you can't do least common multiples, you can't do what? And that's why we have a problem with students not being able to do fractions, not being able to read fractions, not being able to do anything with fractions because they don't learn the first 2 steps. And I've found that out through not only teaching this course, but teaching basic math and pre-algebra. That's where the disconnect is. All right, that's why people can multiply and divide fractions, but they can't add and subtract because of this right here. These 2 things right here. Okay, so you don't have to write this down. This is just for your information. So we're going to learn how to do this. That's what we're going to learn today. And then I'm going to skip a section and we're going to jump to this. So that way you can see the application of prime factorization. So let's just pick a number. Let's pick 54, what we started with. 54. And I tell you to break it up into its prime factorization, or prime factors. The first thing I want to tell you to do is write down those numbers that I told you to write down before. 2, 3, 5, 7, 11, and sometimes 13. And then I'm going to write a little chart right here. And I'm going to put 54 right here. Now here's where I need to go in and tell you about the way that you've learned it in the past. Because there's 11 students in here, and there's probably 3 of you that's going, well, I learned how to do factor tree. Well, again, that's a problem because the factor tree doesn't work well with the greatest common multiple. Okay? So I can either teach you the factor tree and then teach you another way, or I can just teach you this way and forget the factor tree. And I found that it helps when people don't do the factor tree because they don't get confused. All right? So I'm not going to show the factor tree, and if you don't want to learn it my way, then do it your way, but don't whine when you get them wrong when we do the greatest common divisor. So, what number will go into 54? Those numbers right there. Which one? 2. Will 3 go into it? Yeah. You can use 3. You don't have to use 2, but you can use 2. You can use 3 if you want to. It doesn't matter. Because multiplication is what? It starts with a C. O, M, U, T, commutative. What is commutative? I have to say commutative because some people say commutative, and that's like a disease. Okay? Okay, it's not commutative, it's commutative. All right? What does commutative mean? 2 times 3 is the same as what? So does it matter which order you put the numbers in? No, it doesn't. So it doesn't matter whether you start with a 3 or start with a 2. I always start with a 2 because dividing by 2 is, to me, is easier than dividing by 3. All right? Now, sometimes you're not able to use 3. And you have to use, but you have to go through and see if any of those numbers will go through there. So I'm going to go with a 2 because that's just me. So I divide a 2 in there. 2 will go into 54, and this is where your division kicks in. Now, another reason I like to show this method is because it knocks the cobwebs off not only the multiplication tables, but your division tables, which is the opposite of the multiplication tables. 2 times 5 is 10, 10 divided by 5 is 2, 10 divided by 2 is 5. Okay? So if you suck at either one of those, you're going to suck at this until you get it back. All right? I don't want to see any calculators because that's defeating the purpose. All right? That's why you can't do fractions, because you're depending on the calculator, because you don't know how to do this. All right? So kind of refresh your memory on dividing. Do it long division. See if you can do that long division in your head. 2 will go into 5. 2 times. 2 times 2 is 4. 4. That'll leave 1. That'll leave 14. 7. That's what you're supposed to be doing. Unless you just know it's 27, okay? If you know it's 27 or if you do the mental division in your head, that's good. Now, the numbers are going to get bigger. You just try to do that mental division. Just try to do it a little bit more. You may have to go off to the side and do some division in your head. I would much rather you go off to the side than rely on an idiot box to tell you the answer. Okay? This is basic math. You don't do basic math on a calculator. That's not what it's for. That's like using a hammer for a screw. You don't take a hammer and beat a screw into a piece of wood. And you don't use a calculator for basic math. All right? Now, what numbers up here will go into 27? There's only one. That means I want y'all to say something. 3. So you take a 3 and put right here. How many times will 3 go into 27? 9 times, your multiplication table. My goal is to get a 1. That's my goal. That's what your goal is. Okay, so how many times, what number up here will go into 9? 3. 3 will go into 9. How many times? And then 3 will go into 3. 1 time. So we got our 1. That's what we want. This is your prime factorization. Now, there's 2 students in here, 3 students. One student is saying, I have no idea what he just went over. I've never seen that before in my life. If you're one of those people, then when you leave here tomorrow or the next day, or Thursday, or whatever day y'all come back, you will know how to do fractions for the first time in your life. Okay? The second type person is the student that's going, oh, well, I know how to do a factor tree, and that's the only thing I know to do. I don't know what this is. Well, you better learn it. That's all I'm going to tell you. And then the third person is saying, well, I'm not going to do any of that because I do it my way. Again, that's fine. But when we get to the common denominator and we get to the greatest common divisor, you're going to have problems unless you know how to do it. And there may be some of y'all that know how to do it without doing this, and that's fine. But that's not who I'm teaching. The ones I'm teaching to are the ones that don't know how to do it. Okay? And I guarantee you, out of 100 people, 30 people, there's usually about 10 or 15 that's never been taught how to do it the correct way. So I just want to let you know, that's it. So you can rewrite that as 2 times 3 to the what power? Third power, because how many 3's are there? 1, 2, 3. So that's to the third power. Now you can rewrite it as an answer. You could say 2 times 3 times 3 times 3, or the other answer is 2 times 3 raised to the third power. And that's how you do prime factorization. So let's do a nerd. Let's do 144. I'm going to let y'all try. So first of all, we put 2, 3, 5, 7, 11, and 13. Then we draw a chart. And 144. All right, go to it. If you can't do it, then that means you are a failure in life and you should live in a ditch. And you should quit school, drop this class today. That's what it means. You know, I actually, 20-something years ago, when I actually said that for the first time, I had a student complain to my department head that said that I was discouraging students. People, we need a sense of humor. Again, 2 and 3 can go into these. If you have a book, I want you to turn to page 206. I think it's kind of an orange table. Do y'all see it? Is it orange?
Yeah.
Oranges. It's called a divisibility table. You can Google it and print it out if you want to. The divisibility table. Now, again, this is 3rd, 4th grade. Now, I'm not saying that y'all can't do 3rd or 4th grade mathematics. This is 3rd or 4th grade material. What happens is it's so far back that we forget it, okay? The divisibility table is 3rd or 4th grade, and we do put it on the back shelf, and we do forget it. So I would, if I was you, if you don't have a book, get on Google, pull up the divisibility table, hit images, and print out whatever image you like, and put it on an index card or put it inside your book or something, okay? Very important. I usually just use 2 and 3 on everything, and if it ends in 5 or 0, I use 5. Other than that, put the calculator up. Don't need a calculator. I thought y'all had calculators out. Because I know you don't have phones out, because that would irritate me, okay? All right. So what will go into 144? Well, 2 or 3. 3 will go in there, what? 3 will go in there 46 times. You could use that. But I always use 2. Why do I use 2? That's your second yawn. I'm going to throw you out if you do yawn one more time. All right, 2. I use 2 because, like I said, I tell my son, always try to use 2, 5, or 10. Because they're the easiest to what? To divide. Easiest. All right, so 2 will go into 70 what? 72 times. Okay. Well, it ends in 2. If you look at your divisibility chart, if something ends in 2, it's divisible by what? 2. So you learn those tricks. You got to remember them. So 2 will go in there 36 times. Oh, it's an even number. Divide by 2. 18 times. Oh, it's an even number. 9 times. Oh, back to 9. Got to switch gears. 3, and 1. Bingo, we're done. Here is our prime factorization. So that's 2 to the 4th power times 3 to the what? 2nd power. So you can write it like this, 2 times 2 times 2 times 2 times 3 times 3, or you can write it like that. And that's how you use prime factorization. Now, I do not want to see anybody with 6s. I do not want to see, I haven't even wrote a 6 up there. The only 6 I wrote up there was 6 times 9. And I marked out composite factorization because we're not going to even do it. So I don't want to see anything but 2, 3, 5, 7, 11, and 13 on anything that you got. When I come and see a question that you got or whatever, I don't want to see any other numbers besides these. Because what y'all do, what students do, I say, well, what'll go into 144? The first person is 12. Boat and train, they missed both of them. Okay? I did not say anything about using a 12. 12 is not even in that list. Y'all are not working with me. You're going against me. You work with those numbers. That's it. Okay? All right, let's do a nerd. Let's do one a little bit bigger. How about that? Let's do 243. No, let's do it 244. Let's make it simple. 2, 3, 5, 7, 11, and sometimes 13. All right, go to it. So it ends in what? It ends in 4. It even ends in an even number, so you can divide by what? 2. And you can divide by any number that'll go into it, but I try to keep it simple. KISS method. So divide by 2. 1, 2, 2. It's an even number, divisible by 2. 6, 1. Okay, now at this point, we don't have an even number. We have 61. And 61 is not divisible by 2, and it's not divisible by 5. We'll have to see what it's divisible by. It's not divisible by 3. It's not divisible by 7, because we don't have a multiplication table of 7 times anything is 61. 11? No. 11 will only give us 66. So 13? Nope. 13 is possible because 13 times 7 would give us something that ends in a 1, but that's it. 61 is a what? Prime number. Now, look up prime numbers. Go to Google, look up the list of prime numbers, and then print that out. Some people will give you a whole page of about 150 numbers that you can memorize. Okay? 61 is one of those, because 61 is not divisible by any number except for 61 and what? 1. So our answer here I guarantee you some of y'all was trying to find a number that would go into 61. I can't find no number. I'm up to 123. So it's only 61. So our answer is 2 to the second power times 61. Or 2 times 2 times 61. And if you wanted to divide by 61 to get the 1, there you go. All right, you try 81. It's not even. So 2, 3, 5, 7. There's one cough. I heard one cough. You're going to have 2 more. I love 81 because as soon as I throw it up there, I'll say, okay, what goes into 81? Somebody will say 9. Both trained, just them both. Now you know 2 does not go into 81 because it ends in a 1. But what is 8 plus 1? And what goes into 9? So you can divide it by 3. That's your divisibility chart. It's your shortcuts. So I'm going to divide by 3. 3 will go into 8 2 times. That'll leave 21, 27. 3 will go into 27 how many times? 9. 3 will go into 9 3 times. And 3 will go into 3 what? So our prime factorization is 3 to the what? Now, I don't mean to rain on your parade, but if you have a hard time with doing this, that means that you're one of those people that didn't, okay, let me rephrase that. You're one of 2 people. You're either one that didn't learn your multiplication tables or your division tables, which if you remember, you learn your multiplication tables and you know your division tables. Or you've forgotten. I'm going to say that. I'm going to put forgotten them in there, okay? Because that'll give you a chance to kind of relearn them. My suggestion to you is to get you a multiplication table and print it out and go over it and find the patterns, and then you start there. I could show you the pattern that you could just remember. All you got to do is add 5s. All you got to do is add 6s. All you got to do is add 8s. 5 times 1 is 5, right? Okay, 5 times 2 is, or 2 times 5 is 10. You're adding 5s. 6 times 1 is 6. 6 times 2 is 12. You're adding 6s. And all you got to do is count how many times you're adding, and that's, you don't even have to learn the multiplication tables. All right, so there's ways you can learn the multiplication tables. If you learn the multiplication tables, you know the division tables. If you suck at the multiplication tables, then you're going to suck at the division tables, which means you're going to suck at this. Now, what I mean by suck? Suck meaning 15 minutes has passed and you're still working on 81. Okay? That means you need help or you need to brush up. Okay? Question. Right. Complaint. What's your target is to do this. This is your target. 3 will go into A 2 times. 2 times 3 is 6. I'll leave a 2. 21. 3 times 7 is 21. That's, you're thinking in your, 27. You're thinking in your head. That's what your target is. All right. If you're doing that now, then that's good. If you're doing it with long division out to the side, that's okay. But we need to get rid of that scribble on the side. You need to get back into your multiplication tables and your division tables. Now I don't know if anybody's doing that, so don't fuss at me saying that I'm picking on you. I'm not picking on you. All right, let's do 250. Now why is this one easy? because it ends in a 5 or a 0. Look at your, what happens if it ends in 0? What does it say it's divisible by?
5.
5 or 2. Either one. Then you can use either one. I'm not a Raiders of the Lost Ark fan, but I watched that. I watched both of them this weekend. Raiders of the Lost Ark and what's the second one? Yeah, I watched. Yeah, and I still don't care much about it. I'm not into. I mean, I like Harrison Ford, but I just don't like.
I like it more Blade Runner.
I'm not a World War II person. I don't like anything having to do with World War II. I just don't like it. I'm a history person, but I just don't like it. I guess because of the German, I didn't like that. That was awful. All right, so 250. I'm going to divide by 2. The reason I'm going to divide by 2 is most people can divide $2.50 into $1.25, right? And you know, it gets me. I'll ask people what 6 times 25 is, and they'll punch it in their calculator, but if I ask them what 6 quarters is, they tell me it's $1.50. They won't reach for a calculator. They do the math in their head, but when I ask them what 6 times 25 is, they do it on their calculator. You tell me why. I don't know. So divide 2, everybody can divide $2.50 by 2. You get what? $1.25. Now we're into the 5s because the only thing that will go into a number ending in 5 is 5. So you got to use 5. Now how many nickels are in $1.25? Well, there's 5 and then there's 20, so that'd be 25, right? Some of y'all going, what in the hell is he talking about? How many nickels are in 25 cents? And how many nickels are in $1? 20. That's right. So 20 plus 5 is 25. It ends in 5. It's divisible by 5. How many nickels are in a quarter? You better get that one right. Then you'll be like those people that's at the cash register that can't make change. Ask them to spell mom backwards. So that'd be 2, 5 raised to what? You better not be one of those people if I come through there, because I'm going to ask for the manager. I sure do. I'm going to say, you got a person that's running your register that can't do basic math. You need to put them on the floor of office. What's your last name? And you said you worked at with trucking. Yeah. Okay, I can't pick on you. Somebody here runs cash register retail. Okay, Sam's Club. Sam's Club. All right. If you owned Sam's Club, all right, you were the Waltons. Okay, I worked at Walmart for 3 years. Okay, and you were the Waltons. Wouldn't you want people that works on cash registers that do basic math? Now, of course, I know that's not happening. But if let's say I own Hubert's dime store, okay, in Podunk, Anderson, okay, there is no way in Hades that I would put you on my cash register if you couldn't do something like this. Why?
Mess up the money.
Because I don't want the cash register coming up wrong every night.
Sure.
Yeah, I'll never forget. I went down to Charleston one time, and there's a place. It's a good place to eat. It's between Charleston and Georgetown, I think, or Charleston and Myrtle Beach. It's between there. Whatever's between there, I don't know what it is, but it's called Seaweeds or Seaweeds or something. It's an old gas station. It's on the interstate right there. They're going from Myrtle Beach to what's below Myrtle Beach in between? Is it Georgetown? What's between Myrtle Beach and Charleston?
What?
No, I'm talking about down the coast. I thought it was.
Oh.
I don't know what it is, but anyway, there's a place on the left. You go about 5-10 miles. Yeah, about 10 miles, And there's a place on the left, it's an old gas station. What they did, they added around it and put decks and porches and stuff like that. And they turned it into a seafood place. And it is very good. Kind of expensive, but very good. Anyway, I come up to the cash register after I was standing in line to pay. And the bill came up to be like, it was about 3 or 4 of us, and I paid for it. And it was about $70-something and 56 cents. Okay, y'all with me? Let's say $74 and 56 cents. I gave the girl $80. You with me? And then while she was ringing it up, she saw me looking in my hand, and I gave her 56 cents, and she just stood there with this look on her face like, is this a tip? She had no freaking idea what I gave her that 56 cents for. She had to call the manager. And the manager come over there, and you know I lit into him like white on rice. I did. I said, what's the problem? And he said, well, we just have a problem making change sometimes. I said, well, she shouldn't be on the register. And I said, no personalities involved. I said, you're a manager here. You shouldn't have a person that can't do basic math on the register. Anyway, he gave me my change, didn't say much, and I left. Now, is that a smart aleck person, or is that just somebody with business sense? I don't think you should put a person on a cash register, especially at an expensive place like that, and taking in $75, $100 a pop, and they can't make change. No, I don't think you should, because all you're going to do is piss off what? You're going to piss off the customers because you can't make change. Anyway, I know none of y'all are that way because y'all know how to do this, so I'm just picking on y'all. Anyway, y'all ever been to a place like that? I shut down McDonald's on 81 one time. The manager had to go to his office and get a calculator. The manager.
There was this girl at Journeys for a while. We hired her for New Year's Eve stuff, and she did.
At where?
At Journeys, the shoe store in the mall.
I have no idea.
Yeah, but
just say shoe store in the mall.
Yeah. She didn't know how to make change like at all. But he just hired her because he just needed people for the holiday stuff, and that was terrible.
I bet it was.
The holiday stuff, but she didn't know how to make change.
And it was busy, so.
Yeah. I just told her, I was like.
I'm surprised she didn't make a lot of the customers mad.
Yeah.
Because that's the first person that's going to aggravate.
They had it on a schedule, like every 2 hours we would switch positions or whatever. And I just told her, I was like, just
go do something else.
Like, I'll do the register.
Two twins did that.
That's awful. That's awful. I hate to hear that, but you've got people that are like that. They can't spell mom backwards either.
Wow.
All right, so let's go back to those questions and see what we got and see if y'all can do them now. So where am I? Math 1, what class is this? 155? So let's go with 5.1, number 51 in the book, number 14 online. There you go. Okay, now this is 2. Okay, then we'll move into the next section. Finding the least common multiple and the greatest common divisor. Okay, the greatest common divisor. Let's go ahead and tell you what the greatest common divisor is. And this is the great part about this little chart that we use, okay? The greatest common divisor is the smallest the biggest number, sorry, hold on. That will divide, I'm just not hitting the lick pattern. That can be divided into the numbers given. The biggest number that will go into 72 and 148 is the greatest common divisor. The least common multiple and this is very important for y'all to write down because people don't know what they are, is the smallest number that the given numbers will divide into. It'll make more sense after we get the numbers, then you'll say, okay, I understand. This is how we do it. So 2, 3, 5, 7, 11, and 13, and you put both numbers in. 72 and 148. Now there's two parts to this. The first part is to get down to where the real magic ends. The real math ends. And the second part is to make magic math start. Now, first of all, what numbers will go into 72 and 148? Well, they're both even, so you divide by 2. 2 will go in there 36 times, go in there 74 times. They're both even, so divide by what?
2.
18 and what? 37?
Yeah.
What's the problem here? Well, 37 is pretty much a what? A prime number, so you can't divide anything into 37, much less a 2. So at this point, I'm going to take a different color. I'm going to take something red. And I'm going to draw a line under here. And I'm going to put RMS. Real math stops. When the real math stops, this is equal to the greatest common divisor. So the greatest common divisor is what? What's 2 times 2? Okay. What is the biggest number that will go into 72 and 148? Well, somebody's going to say, well, 72, 9 and 8 will go into 72, but 9 and 8 will not go into what? 148. Well, 8 then. Well, 8 won't go into 148. Okay, well, okay, 4. That's what usually people say. Okay, 4. So 4 is the biggest number that will go into both 72 and 148. Does everybody understand that? The biggest number that can be divided into the given numbers. This is a key word. Divided into the given numbers. So 4 is the biggest number. And make sure you write biggest, meaning the largest number that will go into, and underline go into, 72 and 148. Now the reason you need to write this down is because when you get home, if I call you up and say, what is the definition of the greatest common divisor? You'll say, You need to have it written down so you can make sense of the answer when you get it. Okay, because if you come up with 6, you know you're wrong because 6 won't even go into 72. Well, it will 12 times. But 6 won't go into 148. Okay, so you know you gotta have an idea of what your answer is. Okay, so I'm going to erase this down here. I'm going to erase this line right here, and we're going to keep going. What do you mean keep going? We can't keep going. Well, that's where the magic math starts. The magic math is we want to get ones on the bottom, just like before. We want to get ones on the bottom. So we're going to divide by whatever we can to get ones on the bottom. I'm going to do this in blue. Now you can pick whichever one you want. The easy part is, if it's a prime number, then you use that prime number. So 37, we're going to divide by 37. That's going to give us one of the ones. Because you can't divide 37 into 18. So you just bring it down. That's the magic part. Okay? So I'm going to use 37 first because I'm going to get it out of the way. So I'm going to put a 37 right here. Now, will 37 go into 18? No. So you just bring it down. Now you need to put in your notes. You need to draw an arrow and you need to say, over to the side, 37 will not divide into 18, so bring down. And draw an arrow, because that's the magic math part. So what is 37 divided by 37? 1. So we got one of our ones, but we're not finished. We can only use prime numbers. What numbers can go into 18? What prime numbers can go into 18? 3. So put a 3 out there. 3 times what?
6.
Okay, so that'd be a 6. And 3 will not go into 1, so you just bring it down. Three will go into 6. How many times? 2. And bring that down because 3 will not go into 1. And 2, you get a 1 and a what? 1. This, I'm going to take my blue marker. I'm going to put a square, a quadrilateral or a rectangle in blue. That is your least common multiple. So, your least common multiple is 2 times 2 times 2 times 3 times 3 times 37. And of course, this is 8. 8 times 9 times 37. And then 8 times 9 is what? 72? Yes or no? 8 times 9 is 72, isn't it? Now, if you need your calculator, I'll give you permission to use 72 times 37, but you can also do 72 times 30. You could do that. That'd be 3, 6, that'd be 216, 22160. And then 7 times 72 is 494, let's see, 504. And then you can add 504 to whatever I said before, and you could do it in your head. Okay? Either one. Somebody multiply that on your calculator right quick for me. If I say use your calculator, then you can use it. But that's the only time, is when you get down to the bottom. So what is 72 times 37?
2,664.
I'm sorry, what?
2,664.
And that should be your least common multiple. So let's see. Let's punch in 2664. It's a miracle. We got it right. Those of you that can't see it, there it is. Now, what is that number? That is the smallest number that what will go into? 72 and 148 will go into. Now, I want you to write that down if you don't know that. I want you to write it in your notes. We'll go ahead and write it down. 26. I'm sorry. I transpose numbers in my head all the time. 2664. What's fun is when I'm doing a problem on the board and I do the answers in my head and I write down the answers in my head before I write the next step or whatever, it doesn't work too good. All right, 2664 is the smallest number that 72 and 148 will what? Will divide into. And later on, this is going to be your greatest common what? Greatest common denominator. This number right here is your greatest common denominator when we're doing fractions. And some of those fractions that I give y'all are not going to be 1/2 plus 3/4. They're going to be real difficult. 1 over 144 plus 3 over 12. They're going to be 3 or 4 digit numbers in the denominator. Okay, so let's do a nerd. Okay, first of all, does anybody have questions on this so far? I mean, this is basically going to make up, besides the fractions, this is going to make up a large portion of your test. The least common multiple and the greatest common factor, or whatever it's called. I don't call it by its name. The greatest common divisor and the least common multiple. All right, let's do another one. Let's do the one that's soon next in the homework. This is 5.1. Number 5716 online. Okay, Jarrett is setting up chairs for his school band concert. He needs to put 120 chairs on the gymnasium floor. Now, first of all, let's see. That's not really what I want. Let's see if I can do this. Black, rectangle. Come on, move. Damn Russians. I'm trying to cover up the answers because that's what you don't want to look at. There, ignore that. Because first thing y'all do as students is y'all focus on the answer. Y'all sitting there trying to do. Don't do that. Okay? So 120 chairs. And they say in rows of equal size, and there must be at least 2 chairs in each row, and at least 2 rows. So there has to be 2. So 2 is the lowest number that you can use. 2, 3, 5, 7, 11, and 13. 120. 2 will go into 120. How many times? 2 will go into 60, 30 times. 2 will go into 30, 15 times. 5 will go into 15. How many times?
3.
And 3 will go into 1 time. So here's your prime factorization. For 120, it's equal to 2 times 2 times 2 times 2 times 5 times 3. And now you can come up with all kinds of combinations. Okay, I don't know what the answer is. It's raining now. You could have 10 rows of 12. You could have, where did I get 10 rows of 12? Well, here's 10. You automatically zero in on 2 times 5, because 2 times 5 is 10. And my son's 11 years old. He can multiply by 10. You know, 10 times 3 is 30. You just add a 0. 120 times 10 is 1200. You just add a 0. So that's easy. And then you say 4 times 3 is what? So that's 10 rows of 12 chairs, or 12 rows of what? 10 chairs. Now I have no idea what they're asking you on the question. I just want to show you where the mechanics is behind the problem. The mechanics is you break it up into prime factorization. Now, let's move the do-jigger and see what it says, because I have no idea what the question is going to ask. Where's my... Okay, it's not working. There. All right. Can we do 120 rows by 1 chair? No, because it says at least what? 2 chairs. So anything with 1 in it can go out. Is there anything with 1 besides that one?
Yeah.
T.
Where? T? Is that it? Okay, now, 60 times 2, let's see. What's 2 times 2? What's 4 times 5? What's 20 times 2? 40 times 3. Can we do 40 times 3? Yes. 40 times 3. Any other 10 times 40? Is 10 times 40 on there? Or, I'm sorry, 40 times 3 or 40 times... I just said 40 times 3. Is there... There it is. Thank you. I was going this direction. Okay? So, I don't think 60... Let's see, 60 times 2. 2 times 2. Yeah, 60 times 2. Will that work? That's 10. 10 times 2 is 20. 20 times 3 is 60. 60 times 2 is what? 120. So 2 times 60 and 60 times 2. Where's 2 times 60? I guess you're supposed to pick all the possibilities. I don't know what okay. All right, so now what's the next one? 5 rows of 24. So let's take that 5. And that'd be 8 times 3. What's 8 times 3? 24, Hubert. That's right, class. It's 24 times 5. 5 times 24. 5 times 24. And where is 5? Where's 24 times 5? Okay, what else? Let's see the next one. 4 rows of 32. Here's 4. And 2 times 3 is what? 6 times 5 is 30. So that don't work. So that means that 4 times 32 is not 120. So now where's 32 times 4? Is there a 32 times 4?
And on this last column.
Okay, so that one's out. This is not a test question. I would not put this on the test. But it's a good question for you to see what's going on. All right, 20 times 6. Yes, 20 is 2 times 10 times 6. Yep. And 6 times 20 is 5. Next one. 30 times 4. Okay, 30 would be 6 times 5. So 30... 6 times 5 is 30, so that's 2 times 3 times 5, right? 2 times 3 is 6, so that's 30. 30 times 4. Yep, that works. 4 times 30. Where's 4 times 30? Okay, I didn't understand a word you just said. You gotta enunciate.
It's S. This is the last one.
Oh, sorry. Right there. Okay. Okay, next one. 4 by 28. Well, you know that's wrong. Because 4 times 28 is not what? Doesn't end in 0. I mean, that doesn't work. That's 32 something. I mean, that's got a 2 in it. So where's 28 by 4? 12 times 10. Well, 12 is 6 times 2 times 10, so that works. Now, a lot of people say, well, Hubert, why don't you just do your multiplication tables? Well, you can, but the whole point is this is how you come up with these numbers. The prime factorization with the 2 and the 2 in the directions. Okay? 43 by 3, yes or no? No, because 43 times 3 is what? Not 120. I'm looking for, is there any other?
And
3? No, I'm looking for 3 times 28 or 4 times, 3 times 43. I don't see it. All right, 15 times 8. 15 times 8. True or false? Yep. And 8 by 15. 8 by 15. So there's your answers. I'm not going to go through and check all those because it would just take too much class time. It's not, longer time than a regular problem. So your answers, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 out of ever how many is on there, so that's 14 possibilities. And that's how you do that problem. Capiche? Do you understand? Okay, good. All right, last one. The last one is 5.1, 75/20. 75/20. Nah, you don't have to use the Euclidean algorithm, just find it. 30 and 60, just ignore those directions. So find the greatest common divisor. Find the biggest number that will go into 30 and 60. So find that first where the real math stops. They don't want the least common multiple, just want the greatest common divisor. I don't even know what the Euclidean algorithm, it's been so long since I studied Euclid. 2, 3, 5, 7, 11, and sometimes 13. Okay, that's your second call. Lay off the Marlboro Camel Reds. I was in the store the other day getting some diesel fuel, and this little tiny little girl comes in. I mean, not a little girl, she was a woman, because she had her ID, of course. She said, I want a pack of Marlboro Reds, and I went, good God Almighty, you buy as big as one of those cigarettes. She's doing them lethal, the Marlboro Reds. Might as well do a can on, cut off the filter, and just, ugh. Imagine what her breath smells like in the morning. I can't believe they throw the Euclid. I don't even see it in here. Nope. Hey, they use my method right there. They used to use the trees. That's not my method, it's just one I teach. Well, I'm sorry, but I don't see Euclid in your... Do y'all have any idea what they're talking about? It's not even in your book. They don't even have a biography of Euclid, but so they have Eurostate. I don't even know how to say that name. That guy on page 208, he was a very, very smart person. He was the movie something Infinity. Gosh, I can't think of his name. He was the mathematician that didn't have any formal education, couldn't hardly read or write.
Oh, Matt Damon.
No, that was Good Will Hunting. not Road to Infinity, but Journey to Infinity or something like that. And he was sent to Cambridge and never even went to grammar school. And they were teaching him how to write a proof. And he had to learn to write his name first. I mean, pretty much. Can you imagine having that much mathematical ability but can't hardly write a page?
It's on page
Oh, it is? On page what?
213. It's like one small, not even like a paragraph. Last blue word.
Yeah, but that's in the directions, isn't it? Yeah, they don't show you how to do it. That's what I'm saying. In the writing, I don't see in the lesson where they show you how to do it. And I haven't done it in years, so I'm just going to do it the old-fashioned way. All right, what number will go into 30 and 60? 2, 3, 5, 7, 11. Well, they end in 0, so I'm going to do, you can do 5 if you want to. I'm going to do 2. Because 2 is an easy number. 15 and what? Can't use 2 anymore. I got to use 5. Okay? I'll go 3 and 2. Real math stops. Where the real math stops, I have my greatest common divisor. See, greatest common divisor is 10. And that should be your answer. I don't know how they do it with the... Now that's when you would use help me solve this.
Wouldn't 5 into 30 be 6?
Oh, I'm sorry. Yeah, I was thinking of 15. My bad. Thank you. We're not finished. I suck. It's the end of the day. My brain is mush. 5 will go into 15 3 times. 5 will go in there 6 times. Thank you. Okay, then we can go further. 3, 1 time, 2 times. Now the real math stops. Real math stops because there's nothing that will go into 1 and 2 that will give you 1s. 1, yeah, but that's not, you gotta have something in common with both of them. So this is 30. So 30 is the number that will go into both 30 and 60. And that's true. That's the biggest number. Because you can't go to 31, you can't go 40, you can't go 50 because 40 won't go into 30. 31 won't go into 30. So 30 is your answer. I just want to see what they do on the help me solve this. Let's see what they do because I don't see it in the book. View an example. Now, why did they use 4? Don't worry about it. Just ignore that. Just do it by hand. Let's see if I'm right. 30. I know I'm right. 30. And I feel good about myself. Okay, so now, that's 3 questions we just did. Those people that sent those questions, how you feel? Feel good? Or are you going to quit school? You can quit if you want to. It's real easy. All you got to do is just quit coming. All right, who has questions? Okay, let me do 1 or 2 things right quick before y'all start. Y'all can pack